Welcome to the Blazor course. If you don't know what Blazor is, let me explain. I can explain it theoretically, or I just can make it clear at once. What do you prefer? Well, I hope you don't prefer the theoretical definition, because if there is something that this course leaves aside, is the empiricism. I try to explain things in the shortest and simple way possible. So, in a short, Blazor is a Microsoft answer to other modern web development frameworks and libraries such as Angular, React, and others. In other words, it's also a single-page application, it follows the same philosophy that everything is a component and can be reused, and if you have previous knowledge in any of these frameworks that I mentioned in the comparison, you will notice so many similarities. But Blazor doesn't have its own peculiarities. Imagine being able to create your web project using C#. No, I'm not talking about writing C# and then transpile the code to JavaScript. Your C# code will be compiled to Webassembly. Yeah, this is the big deal of Blazor. Webassembly is the DNA of Blazor. Look, JavaScript was created in '95 in just 10 days, with the objective to offer a bit more interactivity on the web pages. However, JavaScript has become the base of web front-end, with rich and complex interfaces, and an endless universe of frameworks, libraries, and subsets that also have endless resources that in the end transpile to pure JavaScript. So far so good, the web development market has already gotten used to work in this fashion. However, there were still two problems to be solved. One is the JavaScript itself that's not compiled, and the other is the JavaScript that belonged to the Sun Microsystems, today belongs to Oracle, and this scenario led some relevant companies in the sector very uncomfortable. So Microsoft, Google, and Apple, together with W3C Mozilla, formed a consortium for the creation of WebAssembly. WebAssembly is a type of universal open source based on binary code that the browser can understand. It's something relatively new and that is not yet a reality, but it's a good bet that Microsoft is putting efforts and Blazor is part of that. Is the WebAssembly the future? Only time will tell. Now talking a little about the format of the course. Requires at least basic web programming experience in any previous programming language. We will create a web shop, just like this one in the illustration. This web shop doesn't work with values in any currency, it's use points instead, just like web shops made for loyalty programs where you accumulate points and then exchange for products or trips. Recalling that the products displayed in this web shop are all of fictitious brands and models with the intention to not expose content and trademarks. The choice for a web shop was made because a web shop is usually very rich in terms of features that are used on a daily basis in the real world. Then we will have forms validation, navigation, access to REST APIs, error handling, componentization, stylization, rendering, data persistence, services, and etc. Previous C# knowledge is not required for this course. Even because Blazor is something very simple and productive, we will barely need to build a lot of code to create our web shop, but every time a need for the code pops, I will explain the code. I will also avoid using advanced or peculiar functions of C# as much as possible, but when it's unavoidable, I will explain, remembering that previous knowledge of programming is still necessary. I will not explain what a if or a for loop is. You will need to catch with your eyes and understand certain things that are usually intuitive for those who already have some experience with programming, even if minimally in any language. It's not intended for people who need to learn everything about Blazor in details. This course is a very quick course with the intention of giving a big push and make you learn the essentials, so that soon after the course you can start your project with at least 80% of what you usually will face in a real commercial project in Blazor. This means that after this course you will need to learn a little more according to your specific needs, in which case it will be up to you to research what is necessary to complete your knowledge. There are two ways to digest this course. You can just pay attention, or you can create the web shop with me by pausing the video to follow me typing. This is something that varies person to person. The course is totally practical, almost nothing theoretical and almost nothing in PPT. Completely hands-on with practical, short and even course explanation for quick and intuitive learning. Since it's not a complete guide, and as stated also with very little theoretical approach, it may not be interesting for academic purposes. On the same platform, we will find excellent complete Blazor courses, and I encourage you to search for something more complete if you really need. Videos are super short to make it easy the management of the mental fatigue. In a short, this course is for those who have at least some experience in programming, are too anxious or are in a rush, or do not have much patience to listen to many theoretical explanations and need to learn everything today to start to create a project right tomorrow. I hope you like it. Remember that the policies of this platform ensure the student the quality of learning. This means that if you're not satisfied with the course, you have up to 30 days to request a refund after the date of the purchase. Thank you! Server, Webassembly and PWA. These are the three strategies for executing a project in Blazor. Let's cover first Webassembly and Server. Look at these two projects. Just watch, there is no need to create a project. On the left side, I created a new Webassembly Blazor project. And on the right side, I create a new Blazor Server project. Let's execute and see the differences. This is the Blazor server running. Loaded really fast. Now I'm going to run the Blazor Webassembly. I'm using a browser different than Chrome, Firefox, because it can show us some differences in a better way. The WebAssembly application took a good while to get loaded, but I will tell you the reason later. Getting back to the application, well, they are very similar. In fact, identicals. Check the other pages. See that? Identical. Let's check the source code of the main pages. Index page, identical. Counter page, identical. Fetch data page, identical. Survey prompt component, identical. Live menu, guess what? Identical. Should we assume that nothing changes between the WebAssembly application and the server application in terms of source code? Well, it changes, but just a bit, and only in some circumstances. I'm not going to explain point by point, but the main change is in the behavior of directive injections. I suggest you to watch the bonus video about type of classes and services. Returning to the browser, running the WebAssembly app, check the tab network in the development tools. Notice the number of things that the WebAssembly application needs to load. Do you know what is this? This is the Microsoft runtime so that the browser can interpret the binary of Blazor server application. This explains the long loading time. Now the same test on the server application. Look, that loads much more faster. What was loaded here was just a few local files and other files necessary to establish a signal R communication. Just remember that in real scenarios, this virtually instantaneous loading is not realistic. Bear in mind that this computer is also running as a server locally. So you must be thinking, if the source code is identical or changes just a bit, there is no reason to use WebAssembly since it takes a long time to load, right? Well, first thing I have to tell you, This delay in WebAssembly only occurs on the first load, and after that the runtime is cached. The matter of fact is that Blazor Webassembly and Blazor Server, it's all about taking a decision for executing strategy, and both models have their advantages and disadvantages. One of the disadvantages you saw already, which is the need to load the runtime in WebAssembly. However, once the application is loaded, it works much more faster than a server application. It's because the server application works in this fashion. Well, a long time ago, in the age of the mainframes, there was something that we called a central computer, which is the mainframe itself. This central computer used to be accessed via terminals, whose only function was to provide user interface and collect interactions through the keyboard. When I say interface, it means text as an interface and the keyboard used to supply interaction with the central computer. So nothing was processed at the terminals, and the terminals were limited only to collect user inputs and send outputs in visual format. And of course, all of this was done through physical cables. Blazor Server had a very similar architecture. What changed is that the central computer is the server that hosts the Blazor application through something that would be analogous to the cable. It's called Signal R. Your browser is the equivalent to the terminal that connects to the central computer. Got it? Signal R is a persistent real-time connection between the browser and the server hosting the Blazor application. So when a Blazor Server application is launched in the browser, a Signal R connection is established and it keeps receiving notifications about changes on the screen and sending user interactions like a click of a button, for example. This is more or less how Signal R behaves. Imagine a conversation, a chat.
Hey Blazor Server, it's me, I am the application client.
Oh, hello application client. So drawing the browser, a login screen containing a gray background and 2 fields for input.
Okay server, I did.
Okay, I'm waiting for the user interaction.
Hey Blazor Server, I send you the login and password for you to validate.
Received client. Put a div on the center of the screen telling that the login is invalid. Anyway, everything is processed on the server and the user only watches renderings. In WebAssembly, everything is processed locally, and also a WebAssembly application can be perfectly hosted on a static file servers like CDNs or Amazon S3, for example. But where are the disadvantages of Blazor Server? Well, in the scenario of the old mainframes, 20 terminals means 20 cables connected to the central computer. On Blazor Server, 20 people accessing the application at the same time means 20 active connections at the same time and 20 processing at the same time. So, if you create a portal with thousands of people accessing at the same time, it will be necessary to have a serious investment in infrastructure. And another important point, what is this application? It shows the server time. Check the source code. I create a timer that performs a function to update a variable according to the server time. Watch now. I will stop the server. In our mainframe analogy, it's like cutting the physical cable with a scissor. Observe the result. The variable stops to be updated, and the browser stops allowing any kind of user interaction. And it displays a message about attempts to reconnect to the server. So we figured out another disadvantage here. The need for a constant active connection. In times of a mobile internet, this is something to be considered seriously. And finally, I say that a WebAssembly application is more faster, but I haven't explained why. And the reason is quite simple: latency. Remember that when you click on a button, Signal R will send the message to the server. Then the server will respond about what's supposed to be updated on the screen, etc. So there are many incomings and outgoings over the network for every screen change or interaction, so latency is unavoidable. But there is advantages as well. Just to start, your application will be full stack, And despite nobody would do something like that because it would be a very bad practice, theoretically you could place ad hoc passwords in your source code, because it's impossible to access the source code of a Blazor server application from the client or decompile it somehow, since Signal R only sends screen updates and collect interactions. And also another advantage, you can directly access a database or corporate services before rendering data, without the need to access via RestAPI, XML, GraphQL, or any other web data exchange protocol. Remember that web development is not just for creating public websites. We cannot ignore corporate and academic intranets. To summarize, the choice between Blazor WebAssembly and Blazor Server is totally depends on your needs. There is no better or worse, but the most appropriated. And for last, there is the PWA, Progressive Web Applications. Check this iPhone simulator with Twitter running on Safari. By clicking this option, a new menu will open. I will choose the option Add to Home Screen. Look at that, I now have a Twitter icon on my home screen, like a new app. Is it an app? Let's check it out. Well, it looks a lot like an app, behaves like an app, but actually explained in a raw way, it's just a Safari running Twitter in PWA mode. And what it means? Well, it means that despite imperceptible, it's just a Safari running Twitter, but without the button, address bar, etc. Twitter looks just like an ordinary mobile app. There is one more important detail. It's not just about running full screen. All files needed for execution, such as HTML, CSS, and JavaScript files, are stored locally on the mobile device and run offline. Of course, if you have no connection and try to log in, you will not be able to, and it's necessary to configure what assets will be stored locally, but the rendering of the login screen, yes, it's completely offline in Twitter. Well, PWA is a sub-model of execution strategy based on WebAssembly. Let's create a PWA for a better explanation. I choose Blazor WebAssembly app, and then I choose that I want it to be a PWA. Let's run and see what happens. The Blazor sample application that was created runs normally in the browser. What really changed is the few more files on www root responsible for the PWA add-on. Icon, manifest, service work, and others. And the HTML changes a bit to complement the requirements for PWA. And the rest of the source code is also the same. What if you run on the iPhone simulator? Okay, now let's add our app to the home screen. Done, now you have our application on the home screen. Let's run it. So it's actually being executed as PWA. Now I will explain some peculiarities, limitations, and advantages of PWA. It's not just something related to iOS as demonstrated. PWA works on Android as well. You don't need to follow any Apple Store or Google Play Store policies. Often takes less storage space, which makes it a good option for entry-model devices and also discourages users from uninstalling the app to free up storage space. When running on the Android browser, you can create something like a pop-up that, when it detects the execution of an Android device, this will suggest the user to click on a button, so that the PWA can be inserted in the home screen, increasing engagement. On iOS so far, push notifications is not supported. Despite very efficient, don't expect the same performance from a real mobile app. And there is more limitations on iOS, such as not being able to access Bluetooth, device connect to the lightning cable, screen orientation, vibration, and other features. Well, before start the course, naturally we need to install Visual Studio. During all the time, we will be using Google Chrome as a browser. However, I believe that using Microsoft Edge is perfectly possible, but using Google Chrome is a recommended suggestion. Open this URL in your browser. Download the community version. Wait for the download, and when finished, run the installer. If this dialog box appears in your installation, click Continue. Remember that I'm installing Visual Studio in a fresh Windows installation. Now we need to select the options for the proper installation of Visual Studio for our course. Select ASP.NET and Web Development option. This option will allow us to create and execute our projects in Blazor. After selecting, click Install. Done. Installation completed. It would be interesting for you to log in with your Microsoft account, but this is not mandatory. Select the theme for your development interface. Okay, all the steps has been completed. Now let's install Node.js. Point your browser to this URL. Download the LTS version. After downloading, run the installer. Accept the terms. And leave all options in default. If you see this dialog box, click on the checkbox and then Next, and start the installation. After the installation is finished, if this terminal window pops, press any key to allow Node.js installer set up some necessary items. Please accept all modifications requests. Done, we finished the installation of Node.js. As you can see, some errors occurred during the installation, but such errors will not jeopardize our course, so type exit. If you wish to test if the installation of Node.js was successfully, open the Windows PowerShell and type the command on the screen. If the Node version is displayed, then we are all set. So now we have our development environment ready to start the course. See you soon! Let's unzip the zip file in some folder. In my case, I will decompress to the C/course Blazor folder, but you can place it anywhere you wish. The first thing we need to do is to lift our backend server that will be executed locally. Open the terminal and go to the directory that you unzipped the files. Then step to the backend directory. Type npm install to install the backend application modules. Wait for the installation of all modules and after finished, run npm start. Now we have our backend server active. This server should be active and running every time during the course, okay? Don't forget. A brief explanation about this backend. It contains all the REST APIs necessary for user management, logins, orders, categories, and product list. It's extremely simple, and if you wish to browse the source code, feel free for that. See you on next video. Let's say hi to Blazor and understand some very basic fundamentals that will follow us all the time during the course. Open the Visual Studio. Choose a new project. And choose the Blazor app project from the list. And click Next. Let's choose a name for our project. Let's call it PC Shop Webassembly. If the Place in Project in the same directory option is not selected, click Select and then click Create. We need to define the version of .NET that we'll be using and the type of Blazor application in this course. Please use version 5.0. Previously, we put the name of the application of PC Shop Webassembly because we will initially work with the type WebAssembly, so Webassembly for short. After, select the Blazor Webassembly app. Finally, the project will be created and initialized. But we need to do something first. We need to add the assets to the project. Please open the folder containing the files that you have been decompressed containing the course files. What you're going to do is basically put the product's image and the logo of a web shop. Such files will be necessary during the course. In Visual Studio, locate the www root folder and with the second mouse button click on that folder. Select Add and then New Folder. Put the name of the folder as Assets. Our characters in lowercase. Open the folder where you decompress the files and in the Assets folder select the Products folder and the PC Shop logo file. And with the second mouse button click Copy. Go back to Visual Studio and with the second mouse button click the folder that you created with the name of Assets. Select Paste. Now we have all the necessary asset files for the project. Let's go. Execute the project. In order to execute a project, you need to click on the button with a green arrow like a play button. From now, we will press this button all the time, every time you need to execute the project. So every time a Blazor application was created, this will automatically create a very small application for you containing a navigation structure, basic examples, and also the Bootstrap library, which is very popular in web development. You are not obligated to use anything that was set automatically, however, this will help us a lot in this course, so let's use it. As you can see, it's a simple project containing a very simple navigation bar on the side, and on the top you will see links. The right part, the white one that says Hello World, we will always reference the right area as a main. See you on next video. Time to explain about templates. Let's run the project. Look at the red box. It's the area for the navigation bar for the example application. The green box is the area for the application's link bar. The blue box represents where each page will be rendered individually. Let's do a test. Click on Counter at the sidebar. Did you notice that the layout structure remains exactly the same, but what is in blue box has been changed? Now, click on Fetch Data at the sidebar. Happen the same, because the template is what defines the elements that are always visible on the screen. Bear in mind that in real life you may hear a lot of people referring the template as a master page. Now let's see how it works in practice. Don't close your browser, otherwise this will interrupt the project execution. Go back to Visual Studio and click on the Solution Explorer. Open the main layout.razor file in the shared folder. This file is basically the template. It's simple to understand. It has a root div with the size of the viewport, and it contains two other child divs, things that will be rendered on the left and things that will be rendered on the right. On the left side, by judging with the name of the style class, we have already deduced that this will render the navigation sidebar. But where is the HTML related to the navigation bar? And what is that strange markup called nav menu? This is not part of the semantics of HTML. So what's that? Well, this is a Blazor component. I will explain so soon. Back to the template, on the right side, it will render the link bar and pages. In the link bar, we have only one link that takes the user to the blazor.net URL. Now, the most interesting part. Did you notice the @body? Well, all individual pages will be rendered wherever the @body is. See you in the next video. Let's explore the index.razor file located in the Pages folder, which is responsible for rendering the Hello World page. Take a look just at the HTML. We have a hello world with a welcome to your new app below. Oh, another strange markup that's not part of HTML semantics. What's that? Yes, another component, once again. Okay, you must be angels to understand this thing of component, right? No worries, let's forget about the index.razor page for a while and back later on this page. Open the surveyprompt.razor file in the shared folder. This is the component. Explaining in a rogue and most didactic way possible, component is the fusion between HTML code and C# code, resulting in a new HTML markup block that can be consumed by templates pages and even other components. When the surveyprompt.razor component was created, the survey prompt markup became available in any HTML edition of the project. Like any other HTML markup, it can have events and properties. Watch the title property. The value is how is Blazor working for you. Back to the surveyprompt.razor file, take a look. we have an HTML block. Every time this component is called, instead of its markup, a HTML block will appear. Back into the browser. Inspect the rendered HTML in your browser after the phrase "Welcome to your new app." Note that we no longer have the markup survey prompt. Instead, we have the HTML block containing in the survey_prompt.razor file. It starts here and ends here. Memorize this selected HTML block. Returning to the survey_prompt.razor file, notice that this is the same block. Did you understood what is a component after all? Simple, isn't? What about the @code? What's that? Remember when I said that the component is a merging of HTML with C# code? So, @code is a directive that separates the C# code from the rest. There is other directives and you will understand the others over the course. To finish about components, the @title shows where the title variable will render. Later in the course, you will understand the main use cases of in conjunto with the Blazor HTML and how the parameters works. But summarizing, the component has the title parameter on the markup, which after informed is assigned the title variable inside the component in the C# code. See you on next video. Since we have explained the concept of the components, it's time to go back to pages. Open the index.razor file in the pages folder. The index.razor is a Blazor page. I will explain what the @page means, okay? Ignore it for now. So, a Blazor page contains the content that will be rendered in place of the symbol with the body in the template. Take a look at the template page again. Open the main layout.razor file in the shared folder. Here is the rendering point for every Blazor page. @body is an internal variable of the template that points us where each page will be rendered individually. In the index.blazor file, we have the HTML that will be rendered and in this case have a word in markup H1, the phrase "Welcome to your new app" and the survey prompt component. And all of this will be encapsulated in the variable @body of the template at the runtime. And what about the @page? Well, I said that Blazor has few directives, right? Every Blazor page contains the directive @page with the path in quotes that will serve as a trigger for the page to be invoked. If we only have / enclosed in quotation marks, it means that this is the initial page. So, it's not by setting the file name of the page as an index.razor that will make it the initial page, but what is inside the page directive. Demonstrating in practice. At the page directive, change from / to /dog. Now, stop the execution of the project and then run the project again. Check the result. Since we no longer have an initial page, it returns an error because the initial page no longer exists. Now, in the URL, include a /dog. Nice, we have our Hello World page back. Go back to the initial page and change /dog to /cities/Miami and run the project again. Now, go back to your browser and put /cities/Miami. Done. That's pretty self-explanatory, isn't? Wanna some good news? As a side effect of the page explanation, you will have already learned about 80% of how Blazor navigation routes works. To keep you very motivated and encouraged for the course, bear in mind that in the most modern frameworks and libraries for web development, roots are often a topic used to have a long and extensive chapter. So, during the course, I will teach you only the remaining about roots. It's absolutely amazing how the smallest example application is able to show us in an extremely intuitive way how Blazor works under several important aspects. See you on next video. Let's talk about change detection. However, I will not explain along an empirical way, it will be short and in practice, just like everything in the format of this course. Run the project. On the navigation bar, click Counter. Click few times on the blue button. Note that for each click the counter increments. Let's see how this works through the source code. Go back to Visual Studio and open the file counter.razor. It's an extremely simple page, but this will immediately allow us to understand the concept of change detection that is used in most modern web development frameworks and libraries, which despite modern was invented a long time ago. If you already have experience with a modern library or framework for web or mobile development, then you are more than used to change detection. But I need to explain to those who haven't yet in touch with this concept. Be very carefully because working with change detection is highly enjoyable and addictive. You'll not be capable to go back to working on the old-fashioned way anymore. Watch the current count variable. It starts with 0. Check the markup button that when someone clicks calls a code that increments the counter. Check the P markup that we have the current count variable after the @ sign. This represents that the value of the variable will be displayed inside the P markup. Since the variable is already inside the P markup, we don't need anything else to display the variable's content, and every time it changes, this will display on the screen automatically. This is change detection at all. Check this image. It illustrates how the process for interface update works through the Blazor change detect and compares with old-fashioned methods. This illustration is about changing the button text and changing the color of the text. Using jQuery and raw JavaScript, you need to search for the ID of the markup and change the HTML inside the markup, and then inject a CSS property. Using Windows Forms, since a button is an element that's part of the Windows Forms, it's an object containing properties, so you need to change the text and color properties. In Blazor, you just simply mix HTML with variables, starting with the @ sign, and every time these variables are changed, the interface will automatically be updated. Well, that's it. Sorry if you expected something extremely complex and full of explanations and details of something so interesting. It's something simple and beauty. See you on next video. Hey, remember when I said that for Blazor, everything that handles interface as a component? Yes, but I said as well that it's only for learning purpose. However, Blazor needs to understand the way which the interface artifacts will be used. In other words, if this will behave like a page, a template, or a component. The difference between them are these characteristics. No matter what kind is the component, this will need HTML code. After all, it makes sense since we are talking about interfaces. So, HTML is mandatory for components, pages, and templates. And what if I don't place HTML? Maybe some error? Actually, it's not so mandatory as it seems. In theory, a component does not need HTML, but in practice, it's a very hard event. So, for now, we will have the practical side for learning purposes. The @sign code is optional. You may or may not use it according to your needs, and in some circumstances you will decide to use, others may not. Both HTML and the @sign code are common between components. So neither is able to define if the interface element is a component, a template, or a page. Such elements are defined based on some peculiarities, such as a component will never have an @page, nor will inherit layout component base. A page will necessarily have an @page directive and will never have an @inheritance layout component base. And a template will never have an @page and will always have an @inherits layout component base. See you in the next video. Let's set the application clean and ready to start creating the webshop. In the Pages folder, delete the fetchData.razor and counter.razor files and keep only the index.razor file. In the shared folder, delete the surveyprompt.razor file. Open an navmenu.razor file in the shared folder. Since we deleted the counter and fetch data, please delete these two children from the UL markup. Just one more thing, please delete the icon from the home entry, because we will not use icons on the navigation bar. Don't forget to save with Ctrl+S all the changes. And finally, open the index.razor file in the Pages folder. Delete the survey prompt component markup because you deleted this as well, and change the page directive to /. Ready? Let's run the project to see the changes. Well, that's it. We now have the terrain ready to start to code. We only have a sidebar pointing to the home page, and on the home page we have practically nothing, just the hello world greeting. See you in the next video where we will start to code. We are going to set ready our homepage to consume an endpoint that brings us the products we want to see on our homepage. The goal here is to reach that result, this page with this layout. Open your browser and point to that address. Well, this is our JSON structure. But I will give you a hint. If you are using Microsoft Chrome or Microsoft Edge, you can use this extension here, which is the JSON viewer. And now, when we refresh the page, the JSON structure looks formatted for us. Good tip, huh? Anyway, this is the JSON structure of a list of products that will be on the home page. We have the fields, product ID, key, name, category, etc. Since C# is a strong typing language, we need to create a class that represents the data format of a product. Go back to Visual Studio and create a folder called Entities at the root of the project. We will put all of our entities in that folder. Then, with the second mouse button, click on the newly created folder and choose Add and then choose New Item. Always containing several file options will pop. Make sure that on the left side you have selected Visual C#. Then choose at the right side the option Class. Enter the class name of product.cs. We need to put in this class all the properties that corresponds to the data format of a product. You know, product ID, key, name, etc. and associate each type of data such as string, integer, boolean, etc. Let's create together. So we have to create property by property, and this is indeed boring and hard work, okay? So I'm going to give you another very interesting tip. There are several websites where you can select the JSON data, copy and paste the structure on the website, and the website will do everything for you. I will grab this one, which is the first on the list, but you can use any other. I go to my JSON structure, select, copy and paste. After pasted, I click on the convert. So what will happen? This will extract all the names and types for each name and create the getter and setter for the class. And then just copy here and paste here. Save this website to your favorites. We will probably use it few times during the course. We finally have our class. Don't forget to always save by clicking Ctrl S, and from now I will not remind you that every change is necessary to save. We need as well to make our class available to be consumed by other project files. What? Look, we are talking about a web shop, so we hope to see products in many points of our project. Makes sense, right? In fact, in practical terms, entities used to be vital and common data elements of the entire application. In a case of a web shop, products, categories, cart items, and the consumer. So it's not a good idea to instantiate a new class via injection every time we need, right? For our lucky, Blazor has a file at the root of the project called _imports.razor. Open it, please. You will notice another directive called using on each line. The using directive is always used to reference namespace. But what is namespace? It's a C# feature that organizes classes. In Blazor in particular, every time you create a folder at the root of the project and place files.razor and files.cs that will be consumed by other files, this will be organized in namespace. This namespace usually have the project name.the folder name by default, but you can change it if it's necessary. And there is also the root namespace that will always be added automatically when we create the project. It's the one in red. So we need to add our namespace that points to the entities. Add one more line. At using pcshop_wasm.entities. Okay, now any and all files created in the entities folder will become global. will be instantiated only once and injection will not be necessary anymore. See you in the next video. Now that we have our logical data structure, I mean the product entity, we are ready to call and consume our endpoint that will bring us the products to the home page. In Visual Studio, open the index.razor file. Clean up all the HTML on the page and keep only the line containing the directive page. Talking about directives, we will learn another one, the inject directive. The inject directive was made to inject services that will be consumed by files that you create in Blazor. Remember in the previous video when I told that every time you inject a service, this will create a new instance inside the Blazor file that invoked? So when we are talking about injecting services, this can be your classes containing entities like products that was created by you, your classes containing services, and also built-in classes from Blazor itself, or installed through package managers like Nugget, for example. And as I said before, we don't have to worry about injecting the product entity, because in the previous video I already explained how to make it global. Consider that this is already automatically injected in this index.razor file and all the others. Just remind you a bit, so it's better because you can absorb the injection concept which is used constantly in any Blazor project, okay? Well, we need to inject a service that is embedded in Blazor that will make the call at the endpoint, the HTTP client. At the top of the page, add the directive inject to call the HTTP client service and assign that service to the HTTP variable. The format of the inject is, after the inject, you supply the name of the service space the name of the variable. As I said, the name of our variable will be HTTP. Now that we have injected our HTTP client service, we will work with the directive code, where we will place our code that will make the HTTP call and assign it to an array variable. Since we are going to show products, our variable will be called products, and this will be an array of type product. For those who have no experience in C#, explaining a bit more. The product type started to exist since you created the entity called product, okay? Now I'm going to put a code snippet and ask you to pause the video until you finish typing. 1, 2, 3, pause. Let me explain what we are doing. Well, every page component or template may or may not have special functions that control its life cycle. I mean, it's optional. You define such life cycles through functions with specific names. For now, we will use onInitializeTheSync, which will basically be executed only once when invoked, but we will use other types of lifecycle during the course. So when a call to the page happens, an asynchronous task will call the endpoint that will bring us the products for the home page, will be executed and stored in a variable called product. For those who are not used to C#, a task represents a single operation that does not return any value and usually is asynchronous. Any asynchronous operation, no matter returning or not a value, requires the word async in the function declaration. And the override, in this case, is necessary, because every Blazor file, after all, is a class in the eyes of the compiler, and like a class, it contains already the lifecycle functions already defined. If you ignore the override, nothing will happen, because the compiler will perform the standard functions that belongs to the class instead yours. So, returning to the code inside initialize the async, we are making a synchronous call to the JSON endpoint, and we will place the results in the products variable. A wait is required so that the line below will not be executed before ending the HTTP call. If you remove wait, this will not work. We are also invoking the HTTP client service using the HTTP variable, which has several access methods. In this case, we are interested in getting JSON data asynchronously, so we will use getFromJSON_async. You must supply the type of the data that should be received. In our case, it's an array of which must be informed inside the angle brackets. And after supply the type, we need to specify the URL to be called. After the products get loaded, an iterate in the products variable will show us the name of the products in the browser debug console line by line. To display data in the browser's debug console, you should use console.writeLine. Let's execute and see what happens. Run the project. We have a blank page. Open the browser console. Note that we have product names line by line like expected at the code. See you in the next video. Time to fill our home page with products. In Visual Studio, open the index.razor file. Previously, we made product names appear on the console, right? To warm up, let's make it appear on the screen instead of the console. We will always place our HTML above the code directive. Create an H3 markup and put the text featured products. Due to previous videos, you might be thinking that inside the HTML we use the @ just to show variables, right? Well, not really. We can put conditions and iterates and other things as well. But the most important is that everything that contains the symbol @ inside the HTML is interpreted as a dynamic rendering by Blazor. You will understand it easily now. We want products to be shown only when the products variable contains data. I mean, when it's different from new. So put @ with if products different of new, open and close brackets. Select the for each block that we created in the code directive. Cut and paste into the brackets below the if products different of new. Instead of console.writeLine, place the @ prod.name inside a p markup. Ready? Run the project and see the result. We now have the products being displayed inside the page, as soon as the products variable contains data. Extend your knowledge in conditional rendering a bit more, go back to Visual Studio and place the H3 markup line just below of if products. And now add an else block to that if. And inside the else block, add a p markup. and inside that P markup, add the text loading. Well, while the data is being loaded, this will only display loading on the page. Maybe this is too fast to be noticed on the screen. So I'm not going to ask you to confirm this change by executing the project. But looking at the code, this is easily deductive, right? So trust me. Remember change detection? Every time the variables change, such changes will be reflected on the page automatically. Let's go to add a little more details about the products. Add 2 more P markups and put the price and description in each one. Below the P markups, place an HR markup to separate the items. Run the project and watch. We now have the details of each product, line by line on the screen. This demonstration was just for you to understand in a conceptual way how the homepage will show us the products. So, now it's time to make it look more acceptable. In the folder where you unzipped the course files, we have another folder called HTML. This folder contains files in pure HTML using Bootstrap, for example, an empty shopping cart, a login page, another from Sanat, and another called productstyle.html, which is exactly the file that we are going to work on now. This is a product card quite similar to many that you have seen in other web shops. Using the notepad, open the productstyle.html file. We basically have the style and the HTML. For now, just select the HTML without the style and copy to the clipboard. Go back to the index.razor file. Delete the for each block and paste the HTML that you copied. Run the project and watch the result. Something totally strange appeared. It's because we ignored the style shit. Good time to learn how CSS works in Blazor. It's super simple. Go back to Visual Studio, open the Pages folder with the second mouse button, click Add, and then New Item. Select the option Style Sheet from the list. Now pay attention. Each Blazor page or component or template contains its own style sheet. In order to make it happen, it's necessary to put the name of the style file exactly with the name of the page or component or template Blazor and then add .css. So in this case, the name must be index.razor.css. Notice on the Solution Explorer, a child file was created under index.razor. This makes clear that Blazor understands this file as belonging to the index.razor file, so they are already linked automatically without the need to declare the style sheet file. Simple, right? Now go back to the notepad and copy everything inside the markup style and paste into the newly created index.razor.css file. Save and run the project. Eventually, it will be necessary to clear the cache every time you notice that your changes are not taking effect. Not the case here, but keep in mind for future needs. Okay, what you see is a simple and elegant product card. It's also responsive, as you can see. Yes, it's actually completely blank, no image, no text, no information. Let's go to render product on the card. Inside the card, locate the img markup and replace the image with @products with 0 inside the square brackets dot picture. Products with 0 inside square brackets means that we want to retrieve the data at index 0 of the products variable array. In the div whose class is prod-name, replace the product name text with @products with 0 in square brackets dot name. In the div whose class is prod-price, replace $0 with 0 between square brackets dot price. Changes and run the project. Okay, now we have the card showing the photo of the product, the name of the product, and the price of the product. But we want to see all the products, right? So let's go. Below the H3 markup, where the card starts, we will encapsulate the card inside a for each iterate like before. Create the block, select the card, cut and paste into the for each block. Now we need to reassociate the variables within the card's HTML. Replace all products with 0 brackets with prod. Remembering that prod is the variable inside the for each iterate, okay? Save and run the project again, and we will see what happens. Well, we have all the products on the home page now. But this layout is not good. Too big, one under another, very bad, right? For our lucky, we are working with Bootstrap. So let's use Bootstrap classes to make our homepage more elegant by creating a grid. Remembering that in this course we are not covering Bootstrap, so I will explain a very short way. Bootstrap is a framework that makes easy the construction of web pages regarding layout. Instead of wasting a lot of time creating classes, for example, class align image to the center, responsive divs, custom buttons, grid that align elements, etc., Bootstrap can do all of this for you. Just create your interface elements and use the style classes that belongs to the Bootstrap. Hey, I mentioned an example like grids that align elements, right? I think this grid will be a good fit on our homepage. Create a div with the grid container class just below the H3 markup and before the for each. Create another div inside with the following classes on the screen. Now, cut and paste the entire for each block into this div. In the first line of the for each, create another div with the following classes on the screen and move the card into that div. All of these classes that we are using came from Bootstrap, and they will streamline our process of creating a grid to display our products aligned and responsive. Save and run the project and see the result. Voila! Now, in terms of appearance, our homepage is ready, elegant and responsive. But what happens if I try to add something to the cart or click on the quantity arrows on the product card? Well, actually nothing. But I promise to come back to this subject as soon as we start to create our cart, okay? For now, we will focus on products rendering. Congratulations on creating the homepage completely, and see you in the next video. Since we have now a homepage containing featured products, we are going to create something almost identical. The difference is the title that should be the name of the category, and the products displayed must belong to the category. Open your browser and point to that address. These are the product categories of our web shop. Each record contains a numeric ID, another alphanumeric ID called key, and the name of the category. Very simple. The goal is to create a page that when we enter the category key in the URL, it brings us the products belonging to the category corresponding to the informed key. So we are talking about dynamic URLs and how to read such values dynamically. In the Pages folder, create a new page with the name categories.razor. To create, with the second mouse button, click on the Pages folder. Then select Add, and then select Razor component. Set the name as categories.razor. Since we are talking about a page, we need to assign the page directive. Create the page directive and place the /categories like on the screen. Save changes and run the project. Let's test it. In your browser URL bar, add the /categories. Just to remember, the page directive was made to define the roots in Blazor. Well, but now we want a slightly bigger challenge. I will explain you how dynamic URLs works in Blazor. And yes, it's very easy and intuitive. In the code directive, we are going to use something we call parameter decorator. This is the parameter decorator. Below, we have the key variable, which will store the received parameter. Now, in the page directive, we will map the parameter to the variable. Add slash and then key in closed braces. Pay attention on the red square. This means that anything at that position in the URL will be assigned to the key variable. Take a look. Replace the categories text in the markup h3 with the @ sign. Run the project now. Add to URL /categories/hello. Now replace hello with bye. Now replace the bye with anything you want. Can you understand? After /categories, whatever come in will be a dynamic parameter and will be stored in the key variable. In markup exit 3, the key variable will be rendered. I told you, it's really simple. No, there are no such things like root configuration files like in many other SPA frameworks. Sorry once again to disappoint you with the simplicity of Blazor. Well, now we need to make our page act as expected, right? Before we start, open your browser and point to this URL. This will show us a JSON data structure containing category data such as ID, key, and description, and also an array of products that belongs to the category. So basically, the challenge is to copy the entire code from the homepage and replace the call from the homepage endpoint to this endpoint, and show on the page only the products of that category, and at the top of the page the name of the category. Let's do it. Open the index.razor file. Copy the entire content of the page and paste it to the categories.razor page. Let's redo the page directive. After the slash, add categories. And then slash key in closed braces. We also need to redo the parameter decorator. At the beginning of the code directive, add the word parameter in square brackets. And just below, create the string variable key, like on the screen. We need to create our data structure to receive the data from the endpoint. So we will create a class inside the Blazor file, instead of calling a class externally. Yes, classes can be internal as well. After task onInitialize async, create a class called dataset with the following properties. Such properties reflect exactly the JSON format as you can see on the screen. Array of products and category information. Now, in the declaration of variables, delete the line containing the declaration of products variable. And create a new variable called category whose type is dataset. And in the HTTP client URL, change the URL to call the products by category as it shows on the screen. Replace the GPU argument with the key variable. Note that we are now concatenating the URL string with the key variable. But there is still something wrong. Visual Studio is pointing us some error. Yes, we also need to change the type of data that we are receiving. We are no longer receiving an array of products, but a dataset type. And the name of the variable is no longer products, it's category. Let's change it. Well, the error is gone. If your changes are successfully, I believe we will see products by category when we call the page. Let's see what happens. Run the project. What we forget? Oh yeah, we need to change the for each, which is no longer an array of products. And we also need to change the name of the variable in the if2 category. But we need to make it work in the products array, which now belongs to the dataset. So let's see the iterate to be made in the dataset product array. Ready? Run the project. At the end of the URL, add /categories/GPU. Well, now I can see the video cards, don't you? So it's working. Almost there in fact. We forgot two little things. Instead of feature products, the category name must appear. And why are the cards out of style? Great time to remember CSS in Blazor. In Visual Studio, in the Pages folder, add an item of type StyleChat. And put the name identical to categories.razor and add .css. Open the index.razor.css file, copy everything and paste it into the categories.razor.css file. Save the changes and run the project. At the end of the URL, add /categories/GPU. Remember that every time you notice that the changes are not being reflected, clear the cache and refresh. Done! Now we have the products with the cards. But the title is still missing. Well, replace the text featured products with the sign at category.name. Save changes and run the project. Again, at the end of the URL, add /categories/GPU. Done, everything working perfect now. Do me a favor. Replace GPU with SSDS in the URL and hit enter. Everything is really working. Can you see the SSDs? See you in the next video. Now that our page showing products by category is done, we needed to make our web shop be capable to navigate between pages. We will put in the sidebar all categories below the home entry, just like on the screen. By clicking on each category, we expect that in the main area of the template, products will be displayed by category. Our first step is to create an entity for categories. In your browser, open this URL. Add another tab in your browser. To use that service, it quickly converts JSON structure into classes to save time. I hope you saved it to favorites. If you didn't, it's okay. Pause the video and type it manually after the code is pasted. Select all JSON content from the categories endpoint. Copy and paste into the other browser tab and perform the conversion. Select and copy only the properties. Now back to the Visual Studio. In the Entities folder, add a new C# class named category.cs. Paste the copied content inside the brace in the class declaration, as it seems on the screen, and save. Now we need to make the sidebar of the web shop. Invoke the category endpoint and render the items in the selected category in a way that when we click it navigates to the selected category. Save pending changes. In the shared folder, open the navmenu.razor file. As you can see, this only has the home item. The challenge here is quite simple. Make a call to the endpoint, put the data in an array, and below the home item, do a iterate on this array to render the categories. Let's go. At the top of the file, inject the HTTP client service and assign the variable HTTP, just like as already done on the index and category page before. And below the code directive, create the categories variable, whose type is a category array. Since we're going to feed data from an endpoint, when starting the navmenu.razor file, we need to define a synchronous task that will be executed on the initialization. The same async task only initializes the sync method used in other occasions. So create the method just like in the screen inside the code directive. And create the categories variable and assign the variable the result of the JSON in the call to the endpoint, just like in the screen. Don't forget to put the return data type, in this case an array of categories. Back to HTML, below the markup that ends the li that contains the link point to home, add a line. To avoid mistakes, put an @ sign if category is different of null. Open and close the block. Inside this block, we will do an iterate in the categories variable to make the categories get rendered. Now create a for each loop. Associate the cat variable in categories, just like on the screen. Copy the markup block li from home and paste into the for each block. Then replace the home text with a @ cat.name. Save and run the project. Almost there. Categories now appear in the bar. Click in many categories to see what happens. In fact, nothing, because we don't have placed the links yet. Let's do it. Go back to Visual Studio. At the beginning of the for each block, create a variable with the name of length type string and place /categories and concatenate with the cat.k, just like in the video. And in the navlink markup, put the link variable as the value for href, just like in the video. Save and run the project again. Click on Memory to test. Looks like this is actually working, right? Not really. Click for example in Processor. Nothing changed. What about GPU? Nothing has changed either. Why? Do you remember component life cycles? So far we were only using onInitializeTheSync. onInitializeTheSync is executed only once when the Blazor file is initialized. This means that our categories page made just a single call on the categories endpoint and then didn't perform anymore. So we need to change our categories page to make it work with a life cycle that behaves differently. Replace onInitializeTheSync with onParameterSetAsync. onParameterSetAsync and onInitializeTheSync are part of the component lifecycle context. But they have different purposes. Like I said, onInitializeTheSync is executed only once when Blazor file is initialized, and onParameterSetAsync will always be executed when there are changes in the parameters of the Blazor file. Now that we changed it, save the changes, run the project and try again to browse the categories. Can you understand the difference between such life cycles? There are other life cycles that we will cover in the bonus video, but our web shop will only use those two that's most used in a daily basis. Just to make our web shop with a better visual identity, let's add a logo to our navigation bar. Select the text PC Shop WASM and delete. Press Enter to create a new line, to allow to place other elements inside the markup A. Locate the www root folder in the Solution Explorer. In the Assets folder, select the PCLogo.png file, drag and drop into the markup A. Remove the tilde sign in the src property of the markup img. Before the save changes, this is a good time to explain the www root folder. It's also known as a public folder. This usually has files that will be accessed by the project every time a direct call came from the HTML to a file, such as our logo, which is a project asset. Product images files are also contained in this folder, and also Bootstrap and any other assets that need to be loaded by the browser directly in an implicit way. Now save our changes and run the project. We need to put some style parameters in this logo. Let's use the Bootstrap EMG Fluid class. Save changes and run the project. Pretty nice! And finally, explaining a bit more about the navigation bar, open the navmenu.razor file. What is this navlink markup? And how the page that I am is currently highlighted in the bar? Good point, I will explain. Navlink is a part of the Blazor routing system. It behaves just like an HTML hyperlink, you know, the markup A, with a small and useful difference. This is able to make a CSS class active by detecting when the user is on the corresponding page pointing at the href. That's why you can see a highlight in the navigation bar on the page that you are, thanks to Navlink's match property. In practical terms, it adds the active class on the markup. Check the expected element. See you in the next video. Now let's start using Blazor components. Pay attention because components are the most important thing not only in Blazor but to any other modern single-page application framework or library. It's imperative you understanding the fundamentals of components, because it's an amazing shorthand to the project, avoiding code redundancy and make the maintenance much more easy. If necessary, watch this video twice. Well, I'm sure you have noticed how the file index.razor and categories.razor are similar. Almost identical, in fact. Check the code of the index.razor file. Now look at the code of the categories.razor file. Did you notice how redundant those files are in terms of coding? Do you know what happens if we decide to change the price font color to green? You will be forced to change on both pages, and this will not be cool. So let's convert the product card in a component. In the shared folder, create a new Razor component called productcard.razor. Delete the H3 markup line. Open the categories.razor file in the page folder and select all the HTML corresponding to the product card. Cut and paste at the top of the product card.razor file. We also need to transfer the CSS. Create a CSS for the product card.razor component. You already know how to do it, right? Okay, last time. In the shared folder, create a style sheet file with the name productcard.razor.css. Open the file categories.razor.css. Select all, cut and paste into the file productcard.razor.css. Now, the file categories.razor.css no longer makes sense to keep, so delete this file. Always saving all changes. Now, go back to the productcard.razor file. Did you notice that Visual Studio is not happy because the product variable no longer exists? So let's create it. In the code directive, create the prod variable and assign the product type to the variable with the getter and setter. Now, in the top row, add the parameter decorator. Yes, the same parameter decorator that you use for dynamic URLs. Every time a Blazor file needs to receive an external parameter before any code to be executed, it's necessary to place the parameter decorator. In the previous video, it was a page receiving the key parameter. Now it's no longer a page, it's a component receiving the prod parameter. It looks complicated, right? Well, I think I'm wasting my time explaining, because I will demonstrate now in practice and you will indeed understand. Save changes to the productcard.razor file. Go back to the page categories.razor. On the blank line where the product card HTML was before, put the less than symbol and then type PRO. Did you notice that Visual Studio now suggests a markup named product card? So accept the suggestion and close the product card with the greater than symbol. Take a look, it looks like a new HTML markup, right? In fact, product card is not part of the HTML semantics, but a Blazor component is always represented by a markup with this name, and like many HTML markups, it contains properties and events. The HTML markup EMG, for example, has the src property for you to specify the image, right? Well, our product card markup has the prod property. Guess for what? Check it out, did it make sense for you now? Save all pending changes and run the project. Okay, it looks like before, but it's using components. Curious to see the source of HTML in the browser? Okay, let's check. Take a look, our product card markup has been replaced with pure HTML. So when you are coding the project, you will see the components markup, but when running, the component will appear in the browser rendered in HTML. Got it? Hey, we can go beyond and learn a bit more. What about a component calling another component? In the shared folder, create the product.Swiss.razor component. Delete the h3 markup line. Open the file categories.razor. Cut the div containing the grid container class. Ctrl X. And paste in the product.Swiss.razor file. Notice that Visual Studio now detects an error in the for each line. Let's create a parameter decorator and just below the products variable that will be an array of product and will be a parameter to be received by the component. This variable will replace category.products. Okay, now return to the categories.razor file. On the empty line, after you cut the HTML snippet that was transferred to the other file, place the product.Swiss markup. And in the markup, place the parameter products. The value will be the same category.products that was before. Well, now we have a component that has another component inside. The product.Swiss component has the product card component inside. You can have multiple components without limits of depth and quantity. Ready? Save everything and run the project to test. Add /categories/GPU to the browser URL. For the user, this is not relevant, but for us developers, open the categories.razor file. Check the code. Super clean, small and elegant. For us, it makes a lot of difference. And talking about difference, do you remember when I said about component reuse? So open the index.razor file. Select the div that contains the grid container class and everything inside. Clean it. Replace with the product.Swiss markup and place the products variable as a products parameter. Ready? Now our homepage is also super minimalist and using shared components. Save all pending operations and don't forget to delete the index.razor.css file that no longer makes sense. See you in the next video. Now we will create the login and sign up functions of our web shop. There is a lot of interesting things to learn with login and sign up, like forms, interoperability with JavaScript, and event handling in Blazor components, for example. So let's go. In the shared folder, create the form signup.razor file. Also create the CSS file corresponding to that file. In the form signups.razor file, we need to delete the H3 markup. In the folder where you unzip the course files, there is a HTML folder and inside we will see the signup.html file. Open this file with Notepad. Copy the entire block inside the markup style and paste it in the form signup.razor.css file. Go back to the Notepad and copy all the HTML and paste it in the form signup.razor file. Now let's create the page that will receive the component. In the Pages folder, create a file named loginsignup.razor. Delete the H3 markup. And create the page directive pointing to the /loginsignup. Save all changes and below place the markup of the form signup component. We also need to implement a way so the user can access the page with no need to type the page name in the browser URL. So open the main layout.razor file in the shared folder. Let's convert the line containing about by login signup. Replace the about text with login signup. And make this hyperlink point to the /login signup. And delete the target blank to avoid unexpected behavior. Let's check our progress so far. Save all changes and run the project. In the corner of the screen, click Login Signup. Well, the HTML file that you open in the Notepad is a pure HTML signup form using Bootstrap. It basically contains a form with the respective fields such as email, name, age, password, password confirmation, and a button to submit the data. Very simple, no? We are now going to convert this form from standard HTML to a Blazor form. Blazor form works with data models. It means that you need to create a class containing the names and types of each field, and associate the class with the Blazor form. You will understand it's very simple. First, let's create the class. We will place the data models in the models folder, so create a folder with the name models. And create a C# class with the name signupModel.cs in this folder. Since we created a new folder containing classes, one more time we need to add a new entry in the _imports.razor file. Add this entry. Go back to the form signup.razor file. We need to instantiate this class and associate it to a variable, conform highlighted in red. A Blazor form has a different markup than a HTML form, so you need to change the markup form to edit form. And associate the class you just instantiated with the edit form using the model property. So that's it? No, it's not over. The fields in a Blazor form are also different, so we need to replace all the input markups to allow Blazor to recognize the fields. when the field is a string, you must use input text, input number when the field is numeric. It also contains input checkbox, input date, input area, etc. But since our course is for you to understand Blazor, instead make you learn every element and details, I will keep to you the task to explore each one of them out of the course or when you are going to code your own project. In this course, we will only use the input text and the input number, because it's enough for you to absorb the concept of forms in Blazor. So replace all input markups that you receive the text with input text, and for the input age, put input number. Don't forget that the input markups are case sensitive and always start with uppercase. And also remove all properties code required in the inputs. Another peculiarity of Blazor's inputs is that it's mandatory to specify the values. These are usually always assigned to model variables of the form class. So let's add the bind value property to each input and associate the values to the model. Check the red highlights. Let's save any pending changes and check your progress. In the upper right of the browser, click on the link to go to the login sign up screen. There are no errors, but we need to be sure about the values that are being associated. So go back to the HTML code. After the edit form block, place a HR markup and below the following HTML. Let's check the variables. Run the project again. Now put some values in the fields. Can you notice that every time the text box loses Fox, the value is assigned to the variable? This is how the bind value property works for Blazor form inputs. See you in the next video. Now going back to the sign-up form, since we are talking about a form, we need to implement the data constraints, such as check if an email has the format of an email, if age is really an integer, if the password matches, etc. We can define that this web shop only accepts people with at least 12 years old. So let's create a function with a plenty of ifs then else, what do you think? And make it display errors. No way, we don't need this. Blazor forms have a good validation feature called data annotations, and it's pretty simple as well. In the model file of the form, before the namespace declaration, add using system.componentModel.dataAnnotations. Now, above the line containing the email property, add email address in square brackets. Above password confirmation, name and age, put required in square brackets. Everything with the required annotation means that the field must be mandatory. We need to link such validations to the form using the markup data annotations that must be included inside the edit form. I believe that the most appropriate place is below the markup H1. So add the data annotations validator markup below the H1. Save your changes and run the project. Go back to the sign-up, but don't type anything in the fields. Now try click on sign up. Well, some fields have been outlined with red, indicating errors. As you declare such fields as mandatory, Blazor automatically added the invalid class in the inputs with errors, and valid on inputs without errors. Check the inspected elements. Notice the email field and age, this seems to be correct. Well, not exactly. Email is not required for now, but you must have at least the email format, and that's we defined it in our validation. Type dog and go to the other field. See, it's not being accepted. Now put dog at pets.com. Now it's being accepted. And also another class called modified has been added, indicating that the field has different values than the original ones. So let's fix three things. First, ensure that the email field is mandatory. Then, we will define the policy of our webshop requires that the user must be between 12 to 18 years old, and we need to ensure the password confirmation. Going back to the code, in the model class, in the email property, add one more annotation, required. And on the property age, we will add another annotation, range. Range checks if a numeric value matches a specific range. So bear in mind that there are many other annotations like credit card, phone, regular expression, URL, etc. So I suggest you to look at the Blazor documentation to learn more about the others. For now, we will only use this for our web shop. Add the range as displayed in red. Then add another annotation for password confirmation, compare. Enclose the name of the property you want to compare in double quotes. Now save all changes and let's test for the form again. Without typing anything, try click on sign up. Apparently, all required validations are working fine. Now put 10 for the age value and click on sign up. Everything still's red. What about change age to 20? Do this and click sign up. Whoa, now everything is fine with age. Anyway, everything seems to be working fine with our sign up form, but nothing's good enough that you cannot improve. It would be interesting to see appropriate error messages. For example, you have defined the age range, but actually only you know the reason for the field becoming red if someone inputs something below 12 or above 18. In the HTML, Validate Annotations Validator, we will add another markup. Validation Summary. Now save the project, run it again, and try clicking directly on Sign Up. See? A list containing all the errors in the form has been displayed on the page. Have you noticed that the age error is a text that you created? And have you also noted the others were created automatically? If you don't specify the error message, Blazor will display a standard message. To specify an error message, you need to assign a text in error message. Let's place "What's your name?" as an error message in the required field name. Run the project and click Sign Up again. Notice that the form now displays your custom error message. See you in the next video. Well, our signup component should be able to perform two actions: send the data to the new user registration and swap the user to the login screen when the user clicks on the hyperlink. Remember when I said that a Blazor component can contain properties and events like any other HTML markup? So far, we are only used properties for the components, without events. This is the right time to learn the component event feature. When you click Sign Up, the component will execute a method called onSignup that will send the data entered in the form. And when clicking on Already Registered, the component will execute a method called onSwitch that will not send data, will just trigger an event. Blazor event components are always executed via callback. In the code directive of the form signup.razor file, create a parameter decorator of type event callback and assign the variable onSwitch. In the already registered hyperlink, set @onClick equal to onSwitch. On the login signup.razor page, create a void method called doSwitch. Put only the output to the console to test the function, and add onSwitch property to the form signup component and set doSwitch as value. To clarify, when a doSwitch event occurs in the form signup component, this will call the doSwitch function. And in the form signup.razor file, we assign the onClick event to call the onSwitch callback on the hyperlink. An interesting thing here, HTML semantic markup events are all accessible via the @sign. That means, for example, you can place a Blazor function on a mouse over of a div, for example. You can also perform a Blazor function on the click of a button, etc. The same kind of flexibility as in JavaScript. Let's test, save all changes, run the project, go to the form and open the browser debug console. Now click on the hyperlink already registered. Check the console, the Blazor function has been successfully executed. But sadly, we have a side effect here. We are being redirected to the home page. It's because we put our onClick in a hyperlink that points to the empty double quotes, and the Blazor router understands as home. We can solve this in this way. Add another onClick to the hyperlink, prevent default. Just like on the screen. That should do the trick. We will test later because now we need to handle the onSignup event. Like I said, it must return a callback containing the data entered. So add another parameter decorator to the component, with the name of onSignup of type event callback. Since this will return data, we need to inform the data type. In this case, signup model. And for last, we need to associate the callback in the onSubmit event of edit form. In the edit form markup, place the callback as it seems using lambda function. Back to login signup.razor. Create another void method called doSignup. And for argument, the new user variable of type signup model. Add the console output for new user.name. Now, in the component markup, add the onSignup and point to doSignup. Save all changes and run the project. Go to the signup form and open the browser console. First, let's test the switch hyperlink. Clicking already registered. Okay, we can see on the screen that it works. Now just fill your name and click on sign up. Observe the console, the submit is being successfully received, but there is a catch. This should not happen because the form is not valid. So I present you something interesting to replace onSubmit. OnValidSubmit. Replace and try it again. Put your name. Click sign up. See, nothing happens on the console. Now fill the form as best as you can. Bingo! Now it performs the callback. Check your name being displayed on the browser console when you click on sign up. This means that the component is sending the data because the form is valid. So you understood that onSubmit submits the form no matter if it's valid or not, and onValidSubmit executes only if the form is valid, right? There is also the onInvalidSubmit that we will not be using, but I'm pretty convinced that you know how it works, right? Well, it looks like everything is okay with our sign up form. Let's clean up the additional HTML that we placed to observe the variables being assigned. Delete the HR line and the P markups below. See you in the next video. Let's create the login form now. To be very honest with you, we will not learn anything with the login form because everything has already been covered in the sign-up form. The login form is basically the same as the sign-up form with less fields and renamed functions. It's just copy, paste, and adapts. To not extend so much, here we go. In the shared folder, create the formlogin.razor file and create the CSS for this file. Copy the entire CSS from the form signup.razor.css file and paste on the formlogin.razor.css file. And also copy everything from formsignup.razor file and paste to formlogin.razor file. Also create a new file in the models folder named loginmodel.cs. In the signupmodel.cs file, copy only the email and password properties and paste into the class declaration block in the loginmodel.cs file. Add open the namespace using system.componentModel.data notations. Save all changes. Now we have a replica of HTML, CSS, and model of the sign-up form, including the functions. What we are going to do now is really quick and simple. We are going to edit some texts in HTML and delete fields and properties, and rename some methods or functions. In the formlogin.razor file, keep only the labels and inputs for email and password. Delete everything in red. Leave only these two fields, like on the screen. In markup H1, replace please sign up by please login. And on the hyperlink, replace already registered sign in by new user space sign up. On the markup button, replace sign up by login. Now on the line that declares sign up form, replace sign up model by login model. Renames the sign-up form variable by login form. In the line with the callback declaration, replace the type sign-up model by login model and onSignup by onLogin. Going back to HTML in the edit form, put login form as model. And in onValidSubmit, replace onSignup by onLogin. And the invoke-async argument should receive login form. And in the bind values, replace all signup form by login form. Done, our component is finished. Save all changes. No explanation was given because the whole concept and behavior is identical to the sign-up form. We just adapted for a login form. See you in the next video. So now that we have both forms ready and componentized, it's time to implement both on the login signup.razor page and get our page ready to perform the login and signup procedures. Create a variable of type string with the name of mode and assign the default value for login. Also create a void method called doLogin that will receive a login module type as a parameter. Assign the credentials variable to the login module parameter. Just like we did in doSignup, add a console output for the credentials.email variable. Our login signup page will initially display the login form. So below the markup of the form signup component, add the form login component. It has the same onSwitch as form signup and points to the same doSwitch function. But instead of onSignup, this will have onLogin and point to the doLogin function. Let's save and run the project to see our progress. Oops, we have some issue here. Let's solve it. It seems that at least in my module, I copied more things that I should. I will remove this required annotation. Running again. Take a look. Now we have two forms on the same screen. Anyway, open the browser debug console. Put data in both forms and click on the blue buttons and check the results in the browser console. It seems that everything is correct so far. But we just want one form appearing according to the context. So let's add an if block with else to show the components according to the value of the variable mode. Now set the components in their respective place inside the if block. In the doSuite method, we need to change the variable according to the current value. It means if the value is login, changes to signup, and if the value is signup, changes to login. So create an if block just like the one created for the component in the HTML. And change the variables according to our definitions. Erase the line containing the output to the console. Now save and run the project. Go to the signup form and test the hyperlinks responsible for the switch. Okay, now we can switch between forms. See you in the next video. It's the right time to create a user in the database using the REST API. Since you have plans to make HTTP calls, as usual, we need to inject the HTTP client service on the login signup.razor page. Starting obviously with the signup process. The doSignup method will be responsible for making the request for the user creation. Delete the line containing the console output in the doSignup method, and convert the method to an asynchronous task. Different of other occasions, we need to make a call to the endpoint via post method. The return of this call will be a field indicating if it was or not successfully, and another field called data, which contains the data of the stored user and also the ID and the balance in points. It means this will return the data that must be stored in a new entity, user. Let's create the user entity. In the entities folder, add another C# class, user.cs. Pause the video, put these properties. This property represents the user entity. The customer ID field is a GUID containing a unique number for each user, and the balance field is the user current balance. In our web shop, every user starts with 30,000 points to spend. Going back to the login signup file, create a class called response model to fit the data received from the endpoint. Put the property successfully as boolean and data as user. In the doSignup method, put the post call as you see in red. Below the HTTP call, put the code in red to place the return data from the endpoint in the variable data response. And add two console outputs below to test. Run the project and create a new user. Go to signup form. Put random data in the fields. Open the browser console debug and click on sign up. See, we are being able to create a user. So what's next? What we would like to happen after the user is created? Well, when creating a user, we expect the user remains logged in, with no need to go to the login screen again and again, and it would be interesting to see the user being redirected to the home page. So let's do it. Create a new folder called Classes. In the Classes folder, create a file called rightnow.cs. Why this name? To make it easier for you to understand that this is a class that handles the present moment. The data accumulated with the use of the project will be stored over there, like the current login user and the items in the shopping cart, for example. Don't forget to add a new entry to the _imports.razor file. We need to make the user data to be stored in the RightNow class. Add a variable of type user with the name current user. Note that Visual Studio is not recognizing the user type. But how is this possible if we added the entities in the _imports.razor file? It just works for files.razor. In .cs files, it's necessary to declare manually. So add another user entry, pcshop_wasm.entities. And going back to the login signup.razor file, create an instance of our RightNow class. Delete the console outputs that we created. And create a line of code according to the red square. Now the data is being stored at the RightNow class. And finally, the redirect to the home. Since this is not about using hyperlinks, I mean we will navigate programmatically, we need to inject one more service, Navigation Manager. And we will put the code after the RightNow receives the data. Let's test. Run the project. Create another user. See, everything is okay. See you in the next video. Well, I guess I wasn't very honest with you in the previous video. What's the point of instantiating the class right now, assign a value to the class, if this will be local inside the login signup page? Doesn't make any sense. Well, sorry for this, but I have a good reason. Explain to you how other kinds of classes works in Blazor. For example, our RightNow class should store the data and keep the data available to be read globally all through the whole application. That's what we are going to do right now. We will convert this class into a Blazor service. Open the program.cs file at the project root. Add one more entry using pcshop.wasm.classes. In the task main, add the content highlighted in red. From that moment, the right now became a service of type singleton. What is this? Well, Blazor works with three kinds of services: scoped, singleton, and transient. Talking about singleton, which is the one that we are going to use in this project, this will instantiate a class just once, and then all other Blazor pages, components, and templates will be able to read the same data. You understand that every time a class is instantiated, the class starts with the default values. So in the case of the RightNow class that we instantiate inside the page, the values will only be valid inside the context of the page. In other words, I do a login or a sign up, but when I go to the checkout to complete my order, checkout components will not be able to read the user data. But if I create a single instance of the class at the beginning of the application execution, it becomes a common data source and available for all components. In other words, I will set the user once, and when I go to checkout, I just need to read the property value of the class. If the explanation is difficult to understand, watch the Blazor service classes on bonus videos. There will be more examples and explanations. Anyway, I will explain shortly. There is also a scoped service that works like singleton when the application is a Blazor server application, because the persistence is linked to the HTTP request, and the transient is a kind of service that every time a component makes a call, this will create a new instance of the service. See more in the bonus videos. Our webshop will only work with singleton. We need to make a small refactory on our login sign-up page. Right now, it's no longer a component to be instantiated, it's now a service, and like every service, it's necessary to inject. Delete the right now line and inject it on the top. Wanna see something interesting? Open the index.razor file. Inject the right now service. Now just spell it, put this code snippet. Run the project and create another user. Now do you understand how a singleton service works? The login sign-up page assigned the user data to the RightNow class, and now any other Blazor file can read the stored data over there. Now delete the changes we made to index.razor. Save changes. Open the main layout.razor file. Inject the RightNow service. Just about the line with the href for login signup, create the following if block with else. Move the login signup hyperlink into the else. Save, run the project and create a new user. We hope that when a user is logged in, the name will appear in the upper right corner of the screen. So look like it's working. See you in the next video. Since we have the sign up ready, now we will handle the login. Run the project and create the following user. Email john@doe.com. Name John Doe. Age 30. Password 123 and confirm the password. Okay, we need to make John Doe be capable to log in. In login signup.razor, convert the doLogin method to an asynchronous task. Delete the console line and copy out the code into doSignup, because it's very similar. In fact, identical, only tiny difference on the endpoint and the data for the post. At the endpoint, replace signup by signin, and the new user variable must be replaced by credentials. All set, now test using john@do.com as email and 123 as password. See you in the next video. Is John Doe still logged in? If not, log in. If John Doe is still logged in, or if you have just logged in right now, please refresh your browser. Ouch, John Doe is no longer logged in. So we need to make the login persistent in our web shop. A good time to learn about interoperability between JavaScript and Blazor. So what's the plans? Well, we will store the result of login and sign up in a cookie, so that when the user returns, the user credentials will be automatically loaded. And we will do this using JavaScript. If it's difficult, no, it's pretty simple as well. Open the folder containing the course files. In the JS folder, click copy on the file functions.js. In the Solution Explorer, paste the file to the www root folder. Open the index.html file in the www root folder. Add a reference to the functions.js file. Now open the functions.js file so I can explain. It's a file containing only two JavaScript functions, write cookie and read cookie, pure JavaScript. To store a cookie, you call the function and pass the name of the key, the value, and the expiration time in days. And to read, you just specify the name of the key. Open the login signup file and inject the service with this variable. IJS Runtime is the service responsible for interoperability with JavaScript. Create an asynchronous task called write cookies, whose parameter will be the variable dataResponse with the type response model. Now pause the video and type this code snippet. We need to convert the dataResponse to a string before we send, because browser cookies only accept strings. And now this will call the JavaScript function. You enter the function, name and parameters. Done. Very simple. Add write cookies on doSignup and doLogin before the navigate line with await. Let's test. Save our pending files and run the project. Open the Developer Tools. Select the Application tab. Click on Cookies and then HTTP localhost. Perform the login. Check that, our cookie is being stored. Let's make our web shop read this cookie at the startup. In the app.razor file, at the root of the project, which is the startup file, inject the interoperability service with JavaScript, and also inject the write now service. It doesn't have a code directive by default, so create. We will once again write code related to the component lifecycle. So create an anonymous task on initialize the sync. Put this code snippet. We are using JavaScript executing the read cookie function contained in the functions.js file with the user as parameter, which is the name of the key containing the user's data. Save changes and run the project. Check there, now we have a persistent login. See you on next video. And to finish this login and sign up part, let's extend the subject of Blazor components and HTTP client features. We will do this by implementing error handling features in login and sign up. In the login signup.razor file, create the error message variable of type string. In the signup, just below the HTTP response, put this if block. The HTTP client has the eSuccess status code property that tells us if everything went well. Move the lines below into that if block. After all, we are only interested in such actions if everything went well, right? Add an else to that if block. The variable error message will receive the error message from the server. Repeat the same procedure as the if block in do login. So that the login follows the same concept. Okay, now what? Well, let's create a new component to display the message. Error message.razor. Creating the shared folder. Another component? But why this will be different? So far, you have been using components that behaves like HTML markups, but such components never had anything inside the markups, right? What if I tell you that we can also put content in pure HTML inside the components? That's what we are going to do now. The component is very small and you will easily understand. Delete the HTML markup and add this HTML. Go back to the login signup.razor file. The last HTML to be displayed will be this error message variable displaying if the variable is different from new. So add it. Run the project. Since our web shop doesn't have a logout function, delete the cookie containing the localhost and refresh the browser. Go to login and supply an invalid credential and click login. Note the red stripe popping indicating an error with a generic text. Let's change few things. We will display the server error message in the red stripe. Place the error message variable inside the error message component markup. But in order to make this work, it's necessary to change the error message component. In the code directive, place this line of code. And inside the div, replace the static text error with @child content. Save all changes. Run the project. Try now with an invalid login. Done, now the server error appears in the red stripe. What about put the error message in bold? Place the error message variable inside a strong markup. Realize that you are putting HTML directly inside the Blazor component. Now test again. Done, we now have the message in bold. We are talking about pure HTML being received by a Blazor component, and I will explain how it works. Open the error message component. It's time to explain the render fragment. If you want to pass HTML content or even one component inside another, this is possible thanks to a special parameter called the render fragment. In a short, your HTML will be stored in the child content variable. And in the component's HTML, you place the variable where you want to render in the component. Very simple, isn't it? And with that, we conclude all the login and sign up part. Did you notice how much we have already built in our web shop using Blazor? Impressive! We are approaching to the end of our web shop. Did you notice that we barely wrote code even near the end? This is what makes Blazor very interesting, recent and productive. And now let's handle our shopping cart. In this video, we will create the basic functions of the shopping cart. You know, add the items, remove, clear, change quantity. So let's go. We need to create one more entity to represent the item in our cart. Create an entity called cartitem.cs. The most basic shape of a shopping cart item in terms of structure is about the product and the quantity. So please create such properties. Since the shopping cart is something related to the moment, the RightNow class will be responsible for managing the data. Open the RightNow class and add this new cart items property, which is a list of cart items. We will now create the functions that I mentioned. Create the functions in red. Ready? Well, I said we have barely written code so far, but this will change a bit. Not much in fact. These functions need a bit of code to work properly, using C# peculiarities. But don't worry, the functions are very similar, super short, and I will explain line by line. So pause the video and place this code snippet. I will explain now. Well, the add to cart function will add items to the cart. This will receive a cart item as a parameter through the item to be added variable that contains the product and the quantity to be inserted. The first thing we need to do is verify if the product ID is already in the cart through the C# findIndex function. This function searches inside the array related to the condition specified into the parentheses. So through the lambda function, FLT is the variable that represents each record inside the array. In this case, findIndex is looking for the cart items property of the RightNow class records whose product ID is the same as the product ID of the item to be added parameter. The return from findIndex works like this. If 0 or greater than 0, it means that the record has been found and the return value is the index value. But if the return is -1, it means that nothing has been found, which heads us to the line below. If there is no item in the cart, then add the item. However, if the item already exists in the cart, then sum the quantity to the current quantity. Let's work on remove from cart. This will be responsible for removing the product from the cart. To make it easy, copy all the code you created in add to cart and place it in remove from cart. The parameter to be received by remove from cart is the product. So we need to search based on the prod parameter. Replace item to be added.product with prod. For us, only matters to take some action if the index was found. So change the if to greater than -1. And delete the line inside the if and delete the else block. Inside the if, place the cart items property point remove at, and as parameter the index on cart variable. I believe that remove at is self-explanatory. It's about removing an item within a list specifying the index of the record. And for setting quantity on cart, copy the remove from cart code. Delete the lines inside the if. This is easy. Set quantity on cart receives as parameter the product and the quantity that has to be in the shopping cart. So it's just a matter of changing the value of the quantity property from cart index in the index assigned to the value of the quantity parameter received by function. So put that line of code. And finally the function to clear the cart. Put that line of code. In a short, every variable of type list has the clear method to clear the data. Just one more thing to make our life easy. Pause the video and create this function. Now place a call to this function as the bottom line of all the functions that we created. Every change in the cart we can see it via browser console. As the name suggests, this function is temporary and we will delete it later. See you in the next video. Time to code the interface to add items to the shopping cart. Run the project. Look at the product card. It has an up arrow to increase the amount, a down arrow to decrease the amount, and a red button to add to the cart the product with the selected quantity, and between the button and the arrows, of course, a number representing the selected quantity. The challenge is to make the product card to be capable to insert items. Open the product card.razor file. Create the quantity variable of type integer with the default value of 1. Replace the 0 contained in the div highlighted in red with this variable. Create these two functions to increment and decrement the quantity counter. Let's implement the calling for this function on the arrows. Add to the divs that contains the arrows these two calls to onClick event. I said before that all HTML markups events can be accessed using @ in the name of the event, right? But I will reinforce. After the quotation marks, where the cursor is located, type space and then @. Scroll down the suggestion list and notice that we have onBlur, onClick, onFocus, onMouseDowns, and all the events that an HTML div used to contains. For us, only onClick matters, but bear in mind that you have all this infinity of possibilities. So we add increment and decrement to each arrow. Let's test, run the project. All products start with the quantity equals to 1 as defined. Now click the up arrow on some cards. Okay, now try to click on down arrow. We have to improve. It's not interesting to allow the user to select less than the initial amount. Go back to the component code. Add this if block. We don't need to test, but now will no longer be possible to decrease the amount for anything below 1. So we have everything ready for the icing on the cake. The button to add the item to the cart. At the top of the component, inject the Right Now service, because it controls the shopping cart. And create the Add to Cart function. Basically, this will create an instance in the cart item variable of type cart item. Then set the product and quantity, and then the Add to Cart function sends the variable. Place the call at the click of the button. Save all operations and run the project. Open the browser console. On the first product on the page, select 2 as the quantity and add. OK, note on the console that the product was added to the cart, now it's 2 quantities. Now change from 2 to 3 and click to add. Since you already had 2 and you added 3, then we have 5. Now click on memory. Add 5 more items of this product that is already in the cart. So now we have 10 quantities of the same item. Return to the home. Randomically add some other items and quantity. Watch the console output. It seems that everything is working. But let's improve the product card. When adding the item in the cart, the quantity should go back to 1. And it would be interesting for the user to see the totals. Open the RightNow class and add these 2 properties. One to show us the quantity of the items in the shopping cart and the other inform us the total purchase price. Pause the video and also add this function to update the totals. Now place a call to this function as the last line of remove from cart, set quantity on cart, add to cart and clear cart. Explaining the function. To update the count properties of the RightNow class according to cart, basically we have the variable Q, which will be increased with the quantity of each item, and a variable A that will be incremented with the sum of each item, according to the for loop in cart items. See you in the next video. Open the main layout.razor file. Add this hyperlink so we can see the totals in the shopping cart. Save all changes and run the project. Open the debug console. Let's watch. Add some items to the shopping cart. Note that the counters in the corner of the screen are not being updated. However, it looks alright on the console output. It's necessary to add some things to the RightNow class. Add this line in red. And in update totals, add this red line. Now open the main layout.razor file and add this code snippet. Save the changes and run the project. I will explain everything, I promise. Add some items to the shopping cart. Well, everything seems to work now. But what happened? Well, in some circumstances regarding change detection, the class needs to supply a notification about a change on the state for all other components that need to handle the data for that component that the handling needs update. This only occurs automatically when an interface event is triggered, such as the click of a button, or in our scenario, on the click of a div. On-click trigger a change of state in change detection, which results in handling updates for the component that triggered the action. Complicated? Let's exemplify, because it's simple. Comment this line in the RightNow class to disable notification. In the product cart.razor file, add sided to the product name the number of items that you have in your shopping cart. Save changes and run the project. Add a few things on the first product of the page. Notice that the quantity of items in the cart is automatically updated on this card. However, in other products it remains 0. Because there is no interface event changing data in that scope, the updated data has not been rendered. Now change the category, go to Processor. Did you notice that all cards are now updated? It's because a fresh rendering was performed. And when a fresh rendering is performed, this always reads the current value of a singleton class. When we click it on the other page, the main template also had to be rendered again. Which is why we can see the updated values in the right corner of the screen. Go back to Home. The same thing, all products were rendered with the current data because a new rendering was triggered. Add more items to the first product on the page. Again, only the card you are clicking is updating. Now going back to the RightNow class, uncomment notify. Run the project again. Add items on the first card. Notice that on the first card, who is responsible for updating the cart, the update is automatically rendered. At the top of the screen, we can see the same update. However, on the other cards, this doesn't happen. It's because main layout have this code at onInitialized. OnInitialized is a call related to the component lifecycle. The difference between onInitialized and onInitialized sync is that this will not perform asynchronous operations. So we are instructing the main template that every time the RightNow class fires an event called notify, the component will be rendered again using the stateHasChanged method. And that will force a new rendering of the data that access the properties of the RightNow class. Copy this code snippet from the main template. Now insert into the product card. Run the project again and add quantities. See that? Now everything is being updated. Let's undo some things that we are put just for you to understand the concept. Remove this code snippet from the product card. And just leave the product name on that line. Just one more thing to finish. So far you have only displaying data on the screen by accessing properties and variables, right? We will do something unnecessary for the project, but it's worth for learning. In the RightNow class, create a new function called getCardTotalItems that will return an integer, placing only one line returning the value of card total items. In main layout, replace card total items with the getCardTotalItems method. Save and run the project. Add some items to the shopping cart. Yes, you can render not only values of variables and properties, but also the value of functions results. And all of this in real time as well. And with that, we concluded the operations of our shopping cart. We just needed to place an order to finish our web shop. So this is what we are going to do now. In the Pages folder, create a page called checkout.razor. And also create the CSS file for that page. And in the folder where you can find the course files, open the cart.html file with Notepad. Copy everything in the style block and paste into the CSS of the checkout. Back to the HTML file, copy all the HTML. Open the checkout.razor and delete the first line containing the h3 tag. Add the page directive with /checkout. Now paste the HTML. In the main layout.razor file, in the line containing the totals, place the hyperlink pointing to the checkout page. Let's check our progress so far. Run the project. Click on the cart. What we have here is a raw HTML template without data, ready for the implementation of the items and totals, and also a button to complete the purchase, which is the place order button. Let's work on the rendering of the cart items. Open the checkout.razor file. Inject the Right Now service. Let's put some rendering conditions. First, show this HTML only if the cart contains items. Create this if block in red and move all the HTML into the true condition. Add an else to notify the user that the cart is empty. Now look at this section of the HTML in red. It only makes sense if the user is logged in, right? So put this block inside a if pointing to the condition that the current user should be different of null. Okay, now look at this block of HTML in red. It represents a shopping cart row. We need to place this block inside a for each loop. So create this red for each loop and move the HTML block to this for each loop. And then replace the static tests with the properties linked to the for each item variable. Image, product's name, product description, the amount, and an expression multiplying the price of the product times the quantity. Enclose the expression in parentheses. Now we are going to change the static test referring to the totals. In this first div in red, replace $0 with @rightnow.cart total amount in parentheses, and then put PTS, that means points. In this other div in red, replace $0 with @rightnow.current_user.balance enclosed in parentheses, and then put PTS. And finally, replace $0 with the expression @rightnow.current_user.balance minus rightnow.cart total amount PTS. You must be curious about why we are putting parentheses on the values to be rendered, right? Well, we have two scenarios that justify such thing. First, expressions requires parentheses. Otherwise, Blazor will render only the contents of the first variable or property or function result, and whatever comes after that, Blazor will consider text. Second, we define that after the number, there will be no space between the value to be rendered and the PTS. If we don't put parentheses, PTS will be merged together with the name of the variables, and this will result in errors. The parentheses in this case define where the content to be rendered dynamically starts and ends. Let's test. Run the project. Click on the top right corner to go to the cart. Okay, we need to add some items to the cart, so do that. Okay, now go back to the cart. Everything seems working. See you in the next video. So far we are only able to add products, and this happens only through the product card. So we need to have more functions like removing products and changing the quantity. Do you still remember the functions created in the RightNow class that we made for this? So create these two functions in checkout.razor. At the click of the remove button, add the call to the remove item. The parameter will be item.product that represents the product of that row. And in the markup input, add this onChange event. The variable e receives data of type change event args that contains data about the event that occurred and sent to setQuantity, the value converted to a string together with the product as another parameter. In the setQuantity function, add this line in red. We are requesting to the RightNow class to set the quantity explicitly for the product being passed as an argument. We are applying a parse because the function in the RightNow class only accepts integers, line in red. There is not much to explain, but basically the RightNow class will remove the specified product of the shopping cart no matter the number of items. Let's test, run the project. Add 5 different items to the shopping cart. 1, 2, 3, 4, 5. Go to the shopping cart. Now try to change the quantity of some items. Note that any change is reflected in the totals. Now delete some items. Deleted items are also being reflected in totals. We have everything ready to complete the purchase. Just to improve a bit, put the product name inside the markup strong to improve aesthetics. And in this HTML template, there is nothing to clear the cart. So add this red line right after the for each block. Let's create the clear cart function. This will also give us the opportunity to play a bit more with JavaScript interoperability. Inject the JavaScript runtime. Go back to the function. Since this is a very sensitive operation, it would be interesting to request a confirmation from the user, right? So let's use the JavaScript native confirm function with Blazor. Create the function in red. Note that the native function conforming JavaScript always returns a boolean. So we have to specify that the function's return will be a boolean. If conformed, the cart will be empty through the clearCart function that we created in the RightNow class. Let's test, run the project. Add some items randomly. Now try to clear the cart. See you in the next video. It's time to complete the order. Inject the HTTP client service on the checkout.razor page. As you probably deduced, we will post to a REST endpoint the order containing the data. So create an asynchronous task with the name of create order. We need to format the data to be sent. Also, in the checkout.razor file, we will create some classes. Check the JSON format that we need to send to the other creation endpoint. We will create two classes to match this format. Create the cart to send items class containing the product ID and quantity, and then create the new order class containing the user ID with customer ID and a list of type cart to send items. And now let's handle the server response when we place the request. Check this JSON. Let's create the response from server class inside the checkout.razor file, containing these properties that are in the same format as the response from the server. Just to explain, the field successfully indicates if the order was accepted or not. Order ID is the order identification. Total is the total amount in points, and new balance is how much the user still can spend on the web shop after the purchase. Go back to the create order function and we will write the code. Pause the video and create this code snippet in red. Basically, what we are doing here is formatting the data to encapsulate in the body variable and send via post to the endpoint /orders/create. Starting with the user ID in customer ID, then a for loop to add the cart items contained in the RightNow class into the cart sent items list with the quantity. After this process, we will send the data to the endpoint via post, and after sent, we need to handle the result of the operation. Create this if block. First, let's handle the exception in the else block. There are few kinds of errors that the backend can predict, but we will address just one of them. The one that sends an error message saying that your balance is not enough to complete the order. So create this if block. Make sure that the JavaScript interoperability service is already injected. Go back to the if block. Add these two lines in red. I could have used our error message.razor component here, but I will take the opportunity to justify the use of the JavaScript alert because I'm sure you must be missing. So this is how we invoke the JavaScript alert. Since an alert doesn't return any data, we can directly place the call after await. The first parameter of an alert is the text and the second is the window title. So let's use this moment also to place another alert in case of a product successfully created. The call to the function is missing. Let's put it on the place order button at the onClick event. Let's test, run the project. Add some items to the cart. Go to the cart. On some items, put a very large amount, 90 for example, for each item. Put quantities to force the new balance to become negative. First, we will test the exception. After ensure that the new balance is negative, click Place Order. Okay, it looks like our exception is working and the JavaScript alert is running. Now change the items in your order so that you don't have a negative balance after purchase. Click Place Order. Done, the order is being created. See you in the next video. Now that the order is already being created, it would be interesting to have a new page informing the order number, the new balancing, and also a small thanks message. On the checkout.razor page, inject the Navigation Manager service that we already used for login and sign up. In Create Order, delete the line that displayed the alert if an order was created successfully. Assign the server response in the order created variable. We will later call a page containing the feedback after the order completed and pass the data via query string. But you need to install a new package called Microsoft ASP.NET Core Web Utilities. With the second mouse button in Solution Explorer, click on the dependency folder and choose Manage NuGet Packages. Search for Microsoft.ASP.NET Core.WebUtilities and install. Don't forget to accept the terms of use. Now going back to the checkout.razor file, we need to create a dictionary type data structure to facilitate sending the data via query string. Add this line at the top of the page containing @ using Microsoft.ASP.NET Core.WebUtilities. Returning to create the order, add these lines in red containing the structure of the data in the dictionary format and the code instructing the navigation manager to navigate to the order completed page with the order ID and new balancing data via query string. Just to explain, we installed the ASP.NET Core Web Utilities package to facilitate the navigation process containing query string data, and then we create a dictionary type object to encapsulate this data to be sent. Now create the order completed.razor page in the Pages folder. Place the page directive pointing to /order completed, and also the Navigation Manager service, and a directive indicating that you want to use web utilities. Let's forget about the layout of the page. Keep it simple. Put this HTML without style. Check these two variables. The query string data will be read at page startup. It means at the uninitialized. Put this code snippet. The URI variable will read all data types from the current URL, and the query strings variable uses the Web Utilities query helper to separate the query string elements. Once separated, we are assigning each value to its corresponding value. We need to render these values on the page. Add each of them enclosed in a strong markup in the HTML. Let's test. Run the project. Place 1 or 2 items in the shopping cart. Click Place Order. Done. As you can see, data is being sent correctly by query string and being displayed on the page. I consider this important for you to learn about using query string because it's a daily basis needs in many projects. And I will teach you one more thing and the last useful need: templates. So far, all of our pages are rendered side by the category bar, right? In the real world, we don't always want to work in this fashion. For example, many internet portals have sign up and login on a dedicated page. So let's do something. This order completed page will no longer be linked to the main template. Let's create a blank template for this page. In the shared folder, create the empty layout.razor file. Delete all content on the page. Every template needs to have @inherits layout component base. So put this line and also this HTML. Now we need to link the order completed page with this layout. Open the order completed.razor file. Add this directive at empty layout to indicate that we want to use the empty layout template. Now run the project and complete an order. Done, main template is no longer present, but I think I forgot something in the template style, so replace the current HTML with this one containing the correct style in empty layout.razor. I will repeat the checkout procedure. Done, now it works good. As I said, the main template is no longer present. I can click on the blue hyperlink and go back to the web shop. So what's next? What else is missing for our web shop? Well, there is nothing left. Of course, it's not a complete web shop. After all, you don't have the I lost my password, you don't have the search for products and other things. But you have enough to have a great Blazor knowledge base. And now we have completed all the features of our web shop. Congratulations! What's this WebAssembly application? It's the standard application that's created when you start a new project on Blazor. Let's debug the application. We can use Visual Studio to debug, but it's necessary to enable the debug. Look, this is how to enable the debug. I don't have much to set up and explain because debugging in Blazor is quite simple nowadays. A few months ago, it was necessary to perform some configuration maneuvers. Well, let's put a breakpoint on the counter. And then run the project. On the counter page, when we click on the button, check what happens. Execution is interrupted, and Visual Studio pops on the screen and allows you to debug. A mouse over shows the current count value. We can also use the pin so that the value of the variable is always visible. In fact, we can use everything that Visual Studio uses to offer nowadays for current developers use it to Visual Studio. I will continue the execution, then stop and continue a few times. Watch. This method is valid for both Blazor Webassembly and Blazor Server. The problem with all new technology for development is the small size of the community initially. This translates into a very little number of available libraries. In our web shop, I demonstrate the use of Blazor with JavaScript in a very basic way. This time we are going to abuse. Let's invade, loot the entire jQuery universe, and bring that ocean of possibilities to the world of Blazor, to increase our power to create excellent interfaces virtually with no limits. We will implement this jQuery plugin, the Fancy Box. Create the WebAssembly Blazor Fancy Box project. Back to the browser. Okay, let's select these lines. I'm going to copy and paste into my index.html at the www root folder. Back to the website. I will copy this example and paste to the index.razor page. We needed to create two variables, image small and image big of type string, and put as value two URLs containing the same image in different sizes, small and big, and place in the HTML the name of the image files with these variables. Let's test, save our operations and run the project. It works, but I think that was very easy. We don't even need JavaScript for that. However, it was clear that we can easily use jQuery plugins in our Blazor applications. Returning to the plugin website, note that this plugin is very rich and contains a range of options. Let's look at the documentation. We can set the initial options via JavaScript. So let's do it. In the index.html file, add this snippet of script. The goal is to make the image open using the rotation effect. In the index.razor, inject the JavaScript runtime, and then this code snippet. OnAfterRenderSync is a part of the Blazor component lifecycle. It's executed every time a handler is completed. This handler can be initial or the result of an update to the interface. We can use the variable of type boolean firstRender to detect if the handler is initial or not. Since we are configuring initial parameter for the face box, and this should only be done once, so we are creating this JavaScript call in onAfterRenderAsync combined with the firstRender flag. Now run the project, let's test. Okay, it works as expected. Let's play a bit more. Back to the FancyBox website. This looks interesting. What is this? Let's try. Create this open message function. We need to convert this example into something that Blazor can understand. So that would be the right way. The class equal to message, I need to use the slash to indicate an escape to make it possible to put double quotes inside a string. So the first parameter of invoke void async always will be the name of the function that you wanna call. And the other parameters will always be passed as a parameter of the function to be called. In this example, initialized FancyBox, because the function we created doesn't use parameters, nothing was passed. We need to find a way to call this function. So add more this div. Let's test, run the project. Click open message. Done, the implementation worked correctly. And this is how an implementation of a jQuery plugin works with Blazor through interoperability with JavaScript. Very easy, agree? We have these 6 types of component lifecycles in Blazor. OnInitialized, OnInitializedAsync, OnParameterSet, OnParameterSetAsync, OnAfterRender, OnAfterRenderAsync. In OnInitialized and OnInitializedAsync, both are executed at the startup like the name suggests. But what does it mean in practice? Well, it's important to understand what exactly an initialize of a component means. It's the moment when the component is loaded or reloaded. The difference between OnInitialized and OnInitializedAsync is that OnInitializedAsync must be used when it's necessary to perform an asynchronous task, such as loading data via API. It's allowed for a component to have both types of initialization if necessary. In our web shop, we used OnInitialize in main layout to create a listener that updates the values in the event of a state change of the RightNow class. And in many other Blazor files from the web shop, we used OnInitializedAsync, for example, at index.razor that needs to load the products via API. Let's talk about onParameterSet and onParameterSetAsync, which is executed every time the component receives the first parameters or the parameter values changes. Bear in mind that it's also possible to combine onParameterSetAsync with OnInitializedAsync. In fact, all component lifecycles can be combined. But back to onParameterSetAsync, let's understand about parameters. Every Blazor file with a parameter decorator means that the component receives parameters. So onParameterSet and onParameterSetAsync will always be executed when a variable linked to the parameter changes. For this category page, if the key variable that loads the category ID changes, a new API call will occur. In the case of this page, the parameter is part of the URL. But it could be a Blazor component. when I refer to a component in this sense, it's about that one that's not a page or a template and can be accessed through this on markup. So, if it was a Blazor component, every time a change occurs in any markup property, onParameterSetAsync or onParameterSet will be invoked. This is the product card. We are not handling with onParameterSet or onParameterSetAsync. But supposing there was a change in the prod property of that component, and the onParameterSet or onParameterSetAsync method was implemented, an event would be executed accordingly. Now let's talk about other types of lifecycle that you didn't have any opportunity during the course. On after render and on after render async. This will occur every time a rendering is completed. Understanding better the rendering point, a rendering can be initial. This one can be detected through a flag passed as a parameter, or an user action that caused a need for an interface update, and also forced code renderings, such as state has changed, which was used in our webshot on several occasions. In the JavaScript interoperability and the use of jQuery bonus videos, I will be demonstrating on after render in practice. Oh, and there is also dispose, which is not officially considered a part of the component lifecycle, but since it reacts every time the component is removed from rendering, it's worth a mention. But unlike other life cycles, you need to use @sign implements and create an iDispose void method. Check the example. We have three types of service classes in Blazor that we can inject as dependencies: singleton, transient, and scoped. Singleton. This type is only instantiated once in the execution of the project. We know that every time a class is initialized, the properties receive the default value. If we change the properties and access the properties in other components, this will always read the values updated. Singleton was widely used during the course. And there is the transient type. This will always start a new instance when the injection occurs. This means that the values of the properties always will be default when injected. And the scoped. Scoped type in WebAssembly works like a singleton, so it makes more sense to use scoped on Blazor server. When we talk about Blazor server, scope is a single connection, or if you prefer, a session. If you are used to server-side web development like ASP.NET and PHP, session is something very familiar to you. Let's see in practice how it works. You don't need to create the project with me, just watch. I'm going to create a Blazor Webassembly project. Now I will create a class with the name number.cs. This class has the random number property, an integer that when started will receive a random value between 0 and 100. Now in the program.cs file, I will declare the class as a singleton service. On the counter.razor page, I will clean up all the HTML and the contents of the code directive, and inject the service and assign the variable number class, and add this markup to show the value of the random number property. Running the project. Okay, the number 81 was randomly generated, and it's being displayed on the screen. Now I'm going to change the page and return to the counter page. Well, number 81 is still there, because even the page being initialized again and the component has been called again, it has already been instantiated before. Now let's change the service to transient. Executing the project. The random number is now 20. Let's change the page and go back to the counter. We have a different number now, 39. It's because the page was initialized again and this generated a new instance of the object. How about switch to scoped? Executing the project. The counter page now shows 91. Let's change the page and return to the counter. Number 91 still remains. As I said, scoped on WebAssembly applications behaves like singleton. So let's test in a server application. I create a Blazor server application now. I create an identical number.cs class and left the counter.razor page the same as the WebAssembly project. Now let's declare the class as scoped. Running the project. The class property started with 15. We can change the page and this still continue with 15. Now watch. I'm opening an anonymous browser instance. Notice that we have a different value, 99. If we switch the pages, this value persists. It's because we started a new session, and in this case, a new instance of the class was created. Now, what happens if we declare a class as a singleton on Blazor server? Running the project, watch. Actually, we have the value of 74. Now I will start a new session in an anonymous instance of my browser. Even when open a new session, the values remains the same. Because, as I said, the class is started only once per execution. A Blazor server application has a single execution, and this is distributed between sessions. The entry base of style of our webshop was made using CSS. But keep in mind that we can also use Sass. Let's try? You don't need to create the project with me, just watch. Let's style the fetchData.razor page. You already know that in order to create a CSS file for a component, you need to create the same folder, a file with the same name as the component, and add the .css extension, right? So nothing more in nature than using the .scss extension instead of .css, correct? Not sure if it's correct, but I think it's worth to try. Okay, looks like this will work. Notice in the Solution Explorer, the Visual Studio is interpreting the SCSS as a file that belongs to the fetchData.razor. I will style the markup table. I rename it to Sass table. In the SCSS file, I placed this style class. I want to apply a red background to the table. Execute the project. It's not working. Why? Well, Blazor don't have a native Sass support. But don't worry, it's very easy to implement. I needed to add a third-party dependency which is a Sass compiler. Let's use libsass builder. Now I will run the project again. Done, I told you it's simple. Note in the Solution Explorer that there is now another file belonging to the fetchData.razor tree. This is the CSS resulting from the compilation of the Sass file. And now let's explore our possibilities a bit more. We are putting green in a variable and we expect the table to become green. I will run the project to test. Okay, now we are really sure that we are working with Sass. What about use the Sass import that's always present in our daily basis? At the root of the project, I will create the covers.scss file. Let's pretend we are on a project where the world cover theme is located in this file. I will create the variable $tableCover and assign the value yellow. Going back to the fetchdata.razor.scss file, I will erase the line we set to color variable. And I will replace with @import.colors.scss. And the color variable will be replaced by tableCover actually located in the imported file. Now running the project. Oops, something went wrong. Oh sorry, it was that line. Missing semicolon. Now running. Check there, we have now our table in yellow. Check the CSS file generated by the Sass compiler.